Okay, hi everyone. I just have a few questions regarding how functions work in Python, both in the lab today, last week, and during my office hours. So I wanted to give a few ways that I think can be helpful for people to see what a function is in Python. So let's get started. Let me share this thing. All right. So the first way in which I think it could be useful or could help to see what a Python function is or how it behaves is to go to like the word function. And other places where you have seen functions is in mathematics, right? Now, I don't want to go into the formal definition of a function just because I might scare people away. But let's go to some functions that we've seen that go from the reals to the reals. For instance, linear functions. Let's look at something like f of x is equal to 3x plus 7. What is this function doing? Well, what this function is doing is basically telling you, if you give me an input, I can give you an output. So imagine I give as an input a 3. This would be 3 times 3 plus 7. That's 9 plus 7, and that's 16, I hope. So I guess like one thing that I guess I want to transmit is that functions, to a certain extent, of course, work sort of like boxes where you give it an input and they give you an output. So something like this. You give it an input to this box called a function, and this function gives you an output. So for instance, in this case, again, if your input is 3, this thing is going to spit out a 16. If you give it a 4, this thing is going to spit out 12 plus 7, which is 19, and so on. And like I know we've seen functions like this, and I guess like one of the first urges that we have is to pretty much just like graph it, right? So do something like this is a 7, and the slope of this thing is a 3. However, I want you guys to see, or like I want to transmit though, that this is basically a summary of this thing. That is, if you give it any input, for instance, with again another 3, then the output is going to be what we had said earlier, which is 16. If you get a 4, it's going to give you a 19. So again, functions, at least the ones that we've definitely seen in the past, like in I don't know, high school, elementary school, stuff like that, behave like this, where you give it an input and it gives you an output. Now, the nice thing about functions in mathematics is that they don't need to be just for one input. So for instance, let's define the following function as the following: f of a v equals a plus b. Then, if I give something like 3 and 4, this is going to do 3 plus 4, and this is 7. This basically means that when you give, I don't know if you can see that when you put a 3 as the first argument or input, and a 4 as the second argument or input, you're basically replacing this a with this 3, and this b with this 4, like this, to produce an output. And this is important because, this is important for a lot of reasons, but this is important at least for the context in which we're seeing it, because functions in Python behave similarly. What do I mean by this? A function in Python, I'm going to first leave our nice little function, not x, f of x equals 3x plus 7 here at the top. This is the syntax, if you want to see it that way, that we've built over the years in mathematics, right? To express a function, or to express what we mean by, I guess, like a very specific function. In Python, the syntax, or the way in which Python does it, is first you need to give the keyword def, which basically means I'm going to create a function, by the way. Then the name of a function, and the name of the function can be pretty much anything. I'm not going to say anything because there are some things that cannot be names of functions, but it can be pretty much anything. So what I'm basically going to try to do right now is translate this function of mathematics into a Python function. So let's give it the same name. Sorry, I don't know why I keep doing this. Let's give it the same name, f. What am I saying here? Here I am saying that f is going to be a function that takes in one argument, the x. So far, what I have basically translated is just this section of my mathematical syntax. Okay, what do we have to do now? So in Python, when we want to get the value of something, when we want to give back the value of something, we do use the keyword return. So in this case, return is basically saying it's when you call this function or when you give an input to this function, give me the value of 3x plus 7. So in the Python world, somewhere lower here, if I do something like f of 3, the value of this thing is going to be 16. Why? Because it's going to be very similar to the mathematical world, where the value of f of 3 is 16. Why? Because I'm going to say calling. When you are calling the function in the mathematical world, what you're basically saying is substitute whatever you put in here, like this 3, with whatever is called x inside. So in this case, it's going to be very, very similar. What you're basically saying is this 3, make it an x, and then substitute it over here, and return whatever the value of this thing is. So that's, I guess, like one way in which Python functions are similar to mathematical functions. One important thing, though, is that functions, as I mentioned earlier, in mathematics and in Python, don't need to have just one argument. They can have many, many arguments. So for instance, I can define the function, let's call it add. This is in mathematics, by the way, or in the mathematical syntax. This is going to be a plus b. Note that in the past, we have named our functions f or g or h. However, we really can just name them in mathematics, at least any way we want to. And even though in I'm studying mathematics as well, and mathematicians are pretty lazy. So that's the reason why they tend to use just like one letter to describe a function that does crazy stuff. However, in programming or in computer science, we really care a lot, at least about how readable our code is for other people and how other people can understand the code that we just wrote. So we try to name our functions with names that can tell you quickly what they're doing. So in this case, even though I'm using a mathematical syntax, I want to call my function add, just because that is pretty much what I'm doing. So to translate this function from the mathematical syntax to the computer science syntax or the Python syntax, again, I need to use the keyword def, which is basically saying, hey, I'm going to create a function, or this is going to be a function. Then I'm going to give it the name, the arguments that it needs, and once more, I'm going to return a plus b. So somewhere, maybe later in the code, if you do something like, I don't know, x is equal to add of of 3, 4, then the value of x is going to be 7. Why? Because this is saying, okay, call this function with these values and save whatever this thing returns into my variable x. This basically is very similar to how we're also doing in mathematics. We can do in mathematics, we don't have variables per se, but let's assume that we have, well, we do have variables, but it's a different type of variables. Let's assume we have something like x is equal of add of 3, 4. Then we know that when we call this function called add, x is going to be equal to actually 7 with these inputs, of course. And the thing with Python too is that, don't take this exactly what I'm saying it, but with Python you can do functions that are, again, don't take this as I'm saying it, but that are more powerful than in mathematics. What do I mean by this? Again, don't take this exactly how I'm saying it, because it's actually not necessarily true. What do I mean by this? Imagine that I want to compute a function, that I want to do, a function that sums two numbers and then squares the sum of them. So let's call it sum and square And as I mentioned, this is going to take two numbers, a and b, and it's going to first do something like sum them. So let's call a variable named sum to equal to a plus b. Then square is going to be equal to sum squared. Then we are going to return square. What am I doing here? Here, what I'm basically doing is, let's actually run it through some input. Let's call the function sum and square and save it in a variable, and square on two numbers. Let's also do 3 and 4. Let's do different numbers. Let's do 2 and 5. Yeah, let's do 2 and 5. Okay, so what am I doing here is basically I'm grabbing this 2 and this 5 and then putting them here in order, unless you specify otherwise. But let's assume right now it's in order. So we know that sum is going to be equal to 2 plus 5, which is 7, because we're doing exactly that. 2 plus 5, so that's 7. And then square is going to be equal to this 7 squared. So that's 49. So we're going to return square, which means that x is going to be equal to 49. And again, this is basically just like doing it in math, right? This is like, in a sense, this function call is just saying, okay, apply whatever rule you have inside you, like all the secrets that you have inside you, to these two inputs. And yeah, I think that's like a nice way to do these things. By the way, like if you wanted to do the same thing in math, you could do something like function composition and other crazy stuff, but let's not go into that. So that's the first way that I want to transmit in terms of how we can see Python functions very similarly to how we see mathematical functions. And one thing that like should hint that something is a function is every time, not every time, but pretty much every time you see like an open parenthesis and a close parenthesis, like where a name, like whatever name is here, this should pretty much tell you that name is a function. It's something that takes in parameters, or maybe no parameters, but that it does stuff like in a mathematical way. Functions that we've seen in the past and that we've used in the past are things like print. Here you pass in a string, right? And what the print function is basically doing is, okay, I'm gonna take the string and I'm gonna put it on the screen. We've seen things something as like random, where this thing basically says, I'm gonna grab no arguments, but I'm gonna spit out a random number. And I know this might seem like, wait a second, how on earth are you going to express that in a mathematical function? But that is actually possible. I'm gonna explain this later just because I don't want to go over this right now, because it can get a little complicated. But anyways, we've seen functions in the past, and pretty much every time, not pretty much every time, but like, yeah, pretty much every time you see something that has an open parenthesis and a closing parenthesis, and then something in the middle, then it's hinting that that is probably going to be a function that you're using or calling. Anyways, let's move on. The second way I like to see functions is as means or as objects that can help me make my code, one, more readable, and two, that can help me copy paste code less often. What do I mean by this? Let's go back to our mathematical way of seeing functions. I know this is going to be maybe a little bit weird, but let's define this function f of x as something really, really horrible. Something like, I don't know, e to the x plus, I don't know, 2 to the x plus, I don't know, x to the 9th plus 3/2 of x to the 8 plus pi x 7th plus, I don't know, tau x cubed plus, I don't know, square root of 2 to the pi-th power of x plus 1. This is a horrible thing, right? But the nice thing, though, is that imagine that I want to calculate the value of this thing when x equals 3, right? So instead of having to do something horrible like e to the a to the 3, again, I want x to be 3, plus 2 to the 3, plus 3 to the 9th, plus whatever. I can easily do this with shorthand by just doing f of, 3. And this, since we defined it earlier, we know that f of 3 is actually going to expand to this horrible thing. But I want, like, the thing that I want to transmit right now is that functions help us, instead of having to copy and paste the whole horrible thing all over again, like we were doing here, I can just say this thing. I can just say, actually, I just want you to do f of 3. I don't really care that much right now how you're doing. I just want you to give me the result of f of 3. And then I'll see what to do with that result. And that's exactly what we're doing here. So in Python functions, even though right now they don't look as horrible, they can get pretty messy. And not only in Python, like pretty much any programming language, code can get really big and really annoying really fast. And one way to like make your code cleaner is by putting things that you know can be reused for different things into functions. What do I mean by reusing them? So for instance, in the previous case where I had like f of x equals something horrible, I don't know if you could see that this is basically helping me reuse an expression. How? I don't have, imagine I knew that x is going to take the values of, I don't know, 1, 2, 3, all the way to 100. Then instead of having to write something like e to the 1 plus 2 to the 1 plus whatever else I had, and then e to the 2 plus 2 to the 2 plus what else I had, and then all these things for like 1 to 100, what I can just do though is write one function or one rule, if you want to see it that way, then just call it on all of these values, or like just input all of these values. And instead of having to do again all of these things 100 times, I can just do something like f of 1, f of 2, f of 3, etc. And I know that this might sound like, okay, that's still doing a lot of work, but it's still way less work and like way less like copying and pasting, or like just writing the same thing over and over again into just a one nice, neat, compressed form, which is exactly what we have over here. And again, like also, like furthermore, we could even put these things in a loop, and then you can make your life even easier in Python. And just like in mathematics, Python functions can help you reuse your code and can help you make things more legible and more compact. Why? Let's assume that we have a function. Sorry, let's assume that what do we want to do? We want to, I guess, imagine you have a list of numbers, like also from 1 to 100, and we want to sum all the pairs like between them. So what do I mean by this? Like we want to do something like, imagine it's 1, 2, 3, 4, 5, whatever. We want to do 1 plus 2, then 2 plus 3, then 3 plus 4, then 4 plus 5, then all these things. Then we can define a function called something like add that takes in two numbers. Again, this is going to be maybe not as intelligent because we have this function already, but anyways, let's assume that we don't. And we can just call it, like, instead of having to do something like 1 plus 2, then 2 plus 3, then 3 plus 4, we can just do something like, I guess like a loop for I in range from, I said 1 to 100, including it. I can just do something like, I don't know, print actually this should be 100. Print add I comma I plus 1. What am I doing here? What I'm basically doing here is first calling this function called add on each of these values. Remember that I is going to take the value first of 1, then of 2, then of 3, then of 4. So what I'm basically doing here is say add 1 plus 2, and then add 2 plus 3, then add 3 plus 4, and so on, and print all of these things. And the point here is that instead of me having to write like 1,000 times a plus b, a plus b, a plus b, which I understand, it's maybe not as annoying. You just have to call one line of code and then do it. Let's look at something that's a little bit more annoying. Let's imagine that this is going to be maybe not as efficient, but let's imagine that we want to compute the nth Fibonacci number. So let's call it Fibonacci n, we're going to do some stuff here. So let's recall what's a Fibonacci number. Fibonacci number is basically something where you start with 1, 1, and the next number is the sum of the two previous ones. So you do 1, 1, 2, 3, 5, 8, 13, 21, I think, and so on. What am I doing here? This 2 is equal to this one plus this one. This 3 is equal to this one plus this one. This 5 is equal to this one plus this one. This 8 is equal to this one plus this one, and so on. So right now I'm just going to write a simple function that computes these numbers. And the reason why I'm doing this is just to show you that there can be functions that can be a little bit longer that can help us make our code more readable and more compact. So to compute the Fibonacci number, first we have to start. There are many ways to do this, by the way, and this is like a very classical computer science program. We have to start with our first two numbers. I'm going to first define a list called fib. This is an empty list. Actually, no, it's not an empty list because we know that the first two values are 1 and 1. I'm going to do for I in range of n. Again, you don't need to understand why I'm doing these things. I just want to show you a function that's a little bit longer. Okay, first I'm going to do result equals 0. Okay, and I'm going to do fib. Actually, here let's start it to n because I already have the first two. I'm going to do fib at I is equal to fib at I minus 1 plus fib at I minus 2. Sorry, I have another bug over here. Let's do it plus 1. So here I can just do a return fib of n. Okay, once again, it doesn't really matter why I did this or how this is working. Let's just assume that it is working. As you can see, this is a lot of lines of code, right? It's maybe not a lot, but it's at least 4. And imagine that I wanted to compute, I had a problem that said compute the first 1,000, no, actually, the Fibonacci numbers from 1,000, from n equals 1,000 to n equals, I don't know, 10,000. One thing that I could do, and this is actually going to be really, really inefficient. Like there are way better ways to do. This. But one thing I could do is instead of having to do this whole chunk of code 1,000 times, or sorry, not 1,000 times, over 9,000 times, just to compute these things, what I could just basically do is say it's called this function those 9,000 times by doing something like this for I in range from 1,000 to 10,000, I don't know, print Fibonacci of I. And this is basically saying, call this thing, however many times this is. This is an I. And the nice thing, though, that I want you guys to see is that I did not have to copy this code like here, like in this chunk again. I just had to call the function, which made my code cleaner in the sense that it's smaller. And also it's more understandable. You know that Fibonacci is going to return you the nth Fibonacci number. Okay, again, this is not the most efficient way. There are actually way more efficient ways to do this, or at least to calculate the Fibonacci number, but let's just assume that this is, I don't know. The point here was that a function that has a lot of code can be reused by can be not only reused, but it can help you make your code cleaner and more compact by just calling it instead of having to copy and paste the whole code all over again, or 1,000 times. Anyways, the last way in which I want to show, I guess, like the power of functions is by, or like how, I guess, they can work with other stuff is by giving a brief analogy into how we can see our Bulls and Cows project or our homework. For the Bulls and Cows project, we have two main files, right? You have Bulls and Cows game.py or something like that. You have something like game.py. The names might be wrong. I'm doing this, I guess, like with no script. But let's just assume that it's these two functions. Okay, so what do we know that is happening with these two files? We know that this game.py is using some functions from bullsandcows.py, right? And the way sometimes I like to see this, or at least when I was starting to program, was that this game.py is sort of like a director of an orchestra. And the bulls and cows, or its methods, the methods are the players. What do I mean by this? The director of an orchestra, I've never been in an orchestra, so I might be saying something really, really stupid. But the director of an orchestra, from what I understand, basically tells the players, for instance, the tempo or how hard they have to play. By hard, I mean like how, whether it's like forte or piano, for instance, or it tells them how, in general, yeah, how things should be working, or like how they should be working like in unison. And the thing here, or like the part of the analogy that I want to like transmit, is that the director of an orchestra basically tells the players, hey, I need you to play this thing. The director is not playing itself or themselves. The director is telling the players, hey, I want you to play this thing. And they're like, what is basically happening is that the players are producing music, returning it to the director, and the director can do other stuff with that music, right? The director can decide, oh, with the music that you're returning, I should make the violin section or like the string section go a little faster, or I'm probably saying something really stupid. But the point is that the director can make decisions based on what the players or how the players are playing. And it's very similar in our game.py and our bullsandcows.py example. Why? Game.py is basically telling or asking bulls and cows to do some things. For instance, to count the number of bulls and to count the number of cows, right? And with that information, the director or game.py is deciding whether to make another turn, for instance, like let the user guess another word, or to stop the game and say, hey, you took this many turns. And that's, I guess, like part of the reason why we like to do functions. It makes our code modular in the sense that we can have something else, like a controller, that can tell these functions just, hey, I need this thing from you. I don't care really how you do it. I just need this thing from you because I'm going to use it to like control the overall picture and control the whole orchestra, and to like make the orchestra produce beautiful music, right? And in our case, to make the program work as we want it to work. So yeah, the nice thing about functions is that it makes your code be modular, and where you can, like, for instance, like imagine you have a violin player that breaks their hand. You're not going to replace the whole orchestra because of that. You can just replace that one violin player, at least for like the concert or whatever, and the whole orchestra should still work fine. I'm probably saying something stupid, but the general idea is that imagine that you had a function that suddenly decided that it's actually too old, that it's too slow, or that does not work exactly as you want it to. Then, instead of like changing the whole thing, like the whole project, you can just change that one tiny little thing, and the orchestra can keep working and maybe even work better than it was before. So yeah, I guess that's pretty much it for me in terms of like how I like to see functions. Hope you enjoyed this video. Yeah, see you in office hours, see you in recitations, see you in labs, see you in class. Have a great week.